Alright, today's video is on classifying triangles, and we've done this before. We've classified them by their side lengths and by their angle measures. We did this way back in Unit 2 or Unit 3, but today we're going to use the Pythagorean theorem to do that. And if you've forgotten, the Pythagorean theorem is a squared plus b squared equals c squared. So we're going to be able to tell what type of triangle based on its angles we have using the Pythagorean theorem. So let's review a little bit. The first thing we want to review is whether or how we tell we can form a triangle. So if you think back, like I said, we talked about this in Unit 3. We've got 3 lengths for a triangle here, 3 lengths for the sides, and we want the 2 smaller sides. Actually, we want the sum of the 2 smaller sides to be greater than the third side. Okay? If the sum of those 2 smaller sides is greater than the third side, then we make a triangle. We don't know what type of triangle at this point, we just know that we make a triangle. Okay, so we're going to do 3 examples here. We're going to start with the first one here. We want to look at the 2 smaller values. We have 2, 3, and 5. Well, 2 plus 3 is 5. 5 is not greater than 5. It's equal to. So these do not make a triangle because the sum of those 2 smaller sides is not greater than the third. Let's look at the next one here. We have 14, 17, and 6. Now this one, switched it up on you a little bit. I did not give you the values in order from least to greatest, so you're going to have to pay attention. Don't just assume that it's the first 2. Here we have to use the 14 and the 6. Well, 6 plus 14 is 20, and 20 is greater than 17, so the sum of those 2 smaller sides is bigger than the third, so these do make a triangle. Now again, we don't know what kind of triangle, but we know that they make a triangle at this point. Last one over here, we have 30, 12, and 17. Well, 12 and 17 are our 2 smaller sides, so we're going to add them together. We get 29. 29 is not greater than 30. It's less than 30, so these do not make a triangle. Okay? So again here, this is important because this is going to be the first thing we check in our problems today. We want to make sure that they make a triangle first, because if they don't make a triangle, there's no point in trying to classify it. There's no point in doing the work because they didn't make a triangle in the first place. So the first thing we want to do is this idea here. Check and make sure they make a triangle and that the 2 smaller sides are greater. The sum of the 2 smaller sides is greater than the third. Alright, so in order to figure out what kind of triangle we have, really these questions today are going to have 4 choices. The first one here, okay, we could not have a triangle at all, and that's what we just looked at. If the 2 smaller sides are less than or equal to that third side, we don't have a triangle, and there's no point in continuing. We don't have a triangle. Now what we've looked at the last 2 days is how to figure out if we have a right triangle, and we use the Pythagorean theorem to do that. Yesterday we said with the converse of the Pythagorean theorem, if, when we plug in those values for the sides, if they work in the Pythagorean theorem, then we have a right triangle. So that's what we check next. First, check and see if we make a triangle. Second, check and see if they make a right triangle. Now, if a squared plus b squared equals c squared, we're good. We know we have a right triangle. But if for some reason a squared plus b squared does not equal c squared, and they do make a triangle, we can use that information to find the other 2 here. And what it's really important is you're just comparing. So you're going to have a squared plus b squared and c squared, a squared plus b squared and c squared. And really what could happen is that the a squared and the b squared could be greater than the c squared. This side over here could be bigger. This side over here could also be smaller, or it could be equal. And that's how we figure out what these sides are. If a squared plus b squared is greater than c squared, then we have an acute triangle. If a squared plus b squared is less than c squared, then we have an obtuse triangle. So what we do first, again, we check and see if we make a triangle. Second, we check and see if it's a right triangle. If it works in the Pythagorean theorem, great. We know we have a right triangle. If it doesn't, then we check these over here. We see if the a squared plus b squared is either bigger or smaller than that c squared, and we decide which type of triangle we have. We've got some examples to do. First one, example 1, we want to know what type of triangle is formed. First thing we want to do is see if we make a triangle. Okay? We add the two smaller sides together, 6 plus 8, that is 14. And 14 is greater than 10. So yes, we make a triangle here. We're going to continue on with our work. Remember, if we get a no there, we're done. We don't have a triangle at all. So the second thing we want to do is we want to see if it's a right triangle. Okay, so we're going to plug it into the Pythagorean theorem, and we're going to see if a squared plus b squared equals c squared. Well, the biggest value has to be the hypotenuse, always in a right triangle. So we're going to plug 10 in for c. And then the a and the b can be either one of the other two values. Normally I plug the smaller one in for a and the middle one in for b, but it does not matter. So we're going to add these together. 6 squared is 36. 8 squared is 64. Add those together, we get 100. 10 squared is 100. These are equal. Okay? Since it works in the Pythagorean theorem, then we know we have a right triangle. All right? You don't have to continue any farther because we figured out what kind of triangle we have. Let's look at example 2. Example 2, what type of triangle is formed here? Again, first step, so we're going to add the two smaller sides together, see if they're bigger than the third, and see if it makes a triangle. So 4 plus 5 is 9, and 9 is greater than 8. So yes, we make a triangle. We're going to continue on with our work. Step 2. And we want to see if we have a right triangle, so we're going to use our Pythagorean theorem. Again, the biggest value has to be the hypotenuse, so I'm going to plug in 8 for C, and then 4 and 5 can go in for A and B. It doesn't matter. Typically, again, I put the smaller one in for A and the middle one in for B. So 4 squared is 16, 5 squared is 25. We're going to add those together and we get 41. 8 squared is 64. Now these are not equal. Okay, so it is not a right triangle. Third step over here, we want to compare those two numbers. Okay, well 64 is greater than 41, and we had these two statements on our previous slide. And it's going to have to meet one of these. Now, we said if c squared is less than ab, a squared plus b squared, it's acute. If c squared is larger than a squared plus b squared, then it's obtuse. If we look up here, c squared is larger than a squared plus b squared, so we know we have an obtuse triangle because it's the greater than sign. Okay? Let's do one more. We have 3 examples here. I'm sure you can figure out by process of elimination which one this is going to be. We've already done right, we've already done obtuse, so we're shooting for acute here. Let's see if we get that. First thing we want to do, check and see if we make a triangle. So add the two smaller sides, two smaller values, and see if they're bigger than the third. 10 plus 17 is 27. 27 is greater than 19, that third side, so yes, they make a triangle. Step 2, we want to see if we have a right triangle. So we're going to use the Pythagorean theorem. Again, the biggest value has to be C, so 19 goes in for C. A and B can be the other two. 10 squared is 100. 17 squared is 289. Use a calculator if you need to. 100 plus 289 is 389. 19 squared, we probably need a calculator for that one. I know it's going to be 361, but use a calculator if you need to. Now these are not equal. 389 does not equal 361, so it is not a right triangle. That means step 3 over here, we're going to compare these two values, 389 and 361. Well, 389 is greater than 361. That means a squared plus b squared is greater than c squared. Okay? Since the c squared is the smaller one, a squared plus b squared is bigger, that tells us we have an acute triangle. Okay? That's the thought process I want you to go through on these. First, check and make sure you have a triangle, then plug it into the Pythagorean theorem. If you get it right, if it works, you get a right triangle, great, you're done. If not, you need to do step 3 and compare and see if it's acute or obtuse. Now we're going to go one step farther here and we're going to do this on a graph. Now on a graph, you're going to be able to plot these. I'm giving you problems on a graph and you're always going to be able to make a triangle. So really when we're doing these on a coordinate plane, you get to skip that first step. You don't have to check and see if they make a triangle because all of these will. We're going to jump right in. What we do have to do, and we did this yesterday, is figure out the distance of each side in order to plug it into the Pythagorean theorem. Give you the distance formula again, x1 minus x2 squared plus y1 minus y2 squared, all underneath the square root. We're going to plug in our values here. So AB would be 2 minus 1 squared plus 3 minus 3 squared. 2 minus 1 is 1. 3 minus a negative 3, that becomes 3 plus 3, so 6 squared. 1 squared is 1, 6 squared is 36, so AB then is the square root of 37. Good. Alright, BC, 1 minus a negative 2 squared plus negative 3 minus 1 squared. 1 minus a negative 2 is really 1 plus 2, so that's 3 squared, plus negative 3 minus 1, that's negative 4 squared. 3 squared is 9, and 4 squared is 16. 9 plus 16, that's 25, so the square root of 25. Now, like I said yesterday in your video, on these particular ones where we're plugging them into the Pythagorean theorem and we have square roots, do not simplify them. It's going to be a shortcut, save you some work if you don't simplify these radicals. Okay, last part here. AC, 2 minus negative 2 squared plus 3 minus 1 squared. 2 minus negative 2 is really 2 plus 2, and that is 4, plus 3 minus 1, that's 2 squared. 4 squared is 16, plus 2 squared is 4, that is the square root of 20. Okay? Alright, now we need to check and see if these make a right triangle. Okay? So we're going to plug them into a squared plus b squared equals c squared. Now, like I said yesterday, the one with the biggest radicand is going to give you the biggest decimal. So that has to be our c value. That tells us here that the square root of 37 has to be our c value. And then we can plug in the other two in any order. Square root of 20 squared plus the square root of 25 squared. Okay? Now again, this shortcut, the square of a square root just cancels that root sign out, and we are just left with the radicand. That's why I told you not to simplify them. So, square root of 20 squared is just 20. The square root of 25 squared is 25. Square root of 37 squared, 37. So we get 45 and 37. Now, 45 does not equal 37, so it is not a right triangle. Now we have to compare. Well, 45 is greater than 37. That meets this property where a squared plus b squared is greater than c squared. That tells us, if we look back, or earlier information, that's this one. Okay, that tells us we have an acute triangle. Alright? So that's the kind of triangle we have, and that's how we would do this problem on a graph. Okay? Again, you get to skip the first step. You're not checking to see if they make a triangle because these will always make a triangle. A little bit of recap here. Okay, some important stuff to remember. The first thing, hypotenuse is always the longest side, so make sure that you plug that in for the c value when you're checking these in the Pythagorean theorem. On most of these, not the ones on a graph, the first thing you want to do is check and see if they make a triangle. Then do your work, because if there's no triangle, there's no way to classify it. You don't want to do all that work for nothing. Then the last reminder here is we use that Pythagorean theorem to decide the type. If it's equal, then it's a right triangle. If a squared plus b squared is greater than c squared, we have acute. If a squared plus b squared is less than c squared, we have an obtuse triangle, and it's really important we remember those. Alright, if you have questions, be sure to post them in the discussion board. If not, good luck on your Schoology assignment.